Alright, so the next question on a portion of the entire linear programming process, which is asking us to figure out those values of x and y that would maximize that objective function there. So the objective function p equals 6x plus 2y. Here we have intersection points, or vertices of our feasible region at these 4 spots. And so then we test each one of those 4 spots. So point A, which is at 0, 0. B, which would be at 6, 0, C at 2, 4, and D at 0, 4. So with each one of these, we find that value, substituting those numbers in there. This one, I don't think this is going to give us a maximum value. It's going to give us a grand total of 0. Not good. How about over here? Now we have 6 times 6. Plus 2 times 0, which would give us a total of 36. Not too bad. Over here, 6 times 2 plus 2 times 4. So that would be 12 plus 8, which would give us a total of 20. Well, B is still our winner so far. And then do the same thing on this last one. 6 times 0 plus 2 times 4. And that would just give us simply 8. So notice what's going on right here. Let's take a closer look. All I'm doing is taking this expression right here. See how that's 6x and that's 2y? So we're doing 6x times 2y. 6x times 2y. 6x times 2y. You get the picture here. The only thing that we're really changing here is we're just changing these numbers that are going right in here, 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 and here, and here. Okay? So now what we're looking for is the max value, the one that gives us the highest value. So sure enough, this is the max, which means that this is our maximum value right here. So the correct answer should be when x is 6 and when y is 0. Number 4, using matrices to solve a system, a pretty beefy one like this where you have 3 equations, 3 unknowns. Using matrices is a great and very efficient way of solving this one. A couple requirements. First, I want you to be able to show me that you can transfer and rewrite this system of equations into a proper dimension matrix, which would look a little bit like this. So as you can see here, pretty much all we do is we take the coefficients, whether they're positive or negative, and put those coefficients right in this 3 by 4 matrix here. Make sure that every variable is in the proper order. See how we have x, y, z, x, y, z. If any of these were out of order, we would need to rewrite it to make sure that we have the proper numbers in there for that. So next, let your calculator take over. Enter that information into the matrix. So move number 1 to get to that matrix menu. Remember, press the second button and then press your x to negative first, which would take you to that matrix menu. We're going to edit this matrix. Don't forget to arrow over to the right and then hit enter to edit the matrix. Since this matrix was 3 equations and 3 unknowns, we have a 3 by 4 matrix. So press your 3, enter, and then your 4, enter, and then we'll skip through the rest because what we're going to do here is enter in all of those numbers from the matrix that you wrote. Alright, so as you can see here, I took the time and put in all that data in there. It's always a good idea to double check to make sure that all of the numbers are properly inputted, especially that last number there. Make sure you put that last one in there before you do anything else. Okay, so next move, after you have the matrix in there, to get the solution, quit, go back to your home screen, so hit second mode, and then press second, matrix again, so x to the negative first. Go over to the right to math. You can press alpha apps to jump there right away, or scroll down until you see reduced row echelon form, also known as RREF. Select that. It'll paste it to the home screen. Then press second, matrix again. And now don't edit the matrix that's 3 by 4. Just select it right here. It's matrix A. Just press enter. Clicky. And then press enter again. Kaboom. There's our answer right there. So then once you have that answer, one of the other requirements, yes, this is required when you show your work for me on this. Here's another thing that is required. I need you to write down your solution matrix. So we have this 1, the 0, and a 0, and a 0, and a 1, and a 0. It kind of feels binary here, doesn't it? And then over here we have the negative 1, we have a 3, and a 0. And then when it comes to reinterpreting what you got right there with this 3 by 4 matrix, remember, what this is really essentially saying is, remember, that first one right there, that was your x. And wasn't this your y? And wasn't this your z? And that was a big old equal sign, an equal sign, an equal sign. So now what we have here is that x must be equal to a negative 1, y must be equal to a 3, and z must be equal to a 0. And that's another required piece. So all those three things you see right there is what I'm going to need to see if you're going to solve that with matrices, folks.